Hello everyone, in this video we are going to learn monotonic sequences. Hopefully at the end of this video we'll have better understanding what means monotonic sequence. The definition: let's have a sequence AN, then 4 points are defined here. What is increasing sequence and strictly increasing? These two are in the same category, and the last two are decreasing and strictly decreasing. What is increasing? A sequence to be increasing, the first term has to be less than or equal to the second, and the second has to be less than or equal to the third, and generally the nth term has to be less than or equal to the n plus 1th term for n element of natural number. But to be strictly, the nth term necessarily it has to less than only, just less than the n plus 1 term. What does that mean? We can take some examples. For example, 2, 4, 6, 8. This is a set of even natural numbers. It is getting larger and larger by 2. So any two consecutive terms, when you compare, the previous term is less than the next term. So this is strictly increasing. We can say this is strictly increasing according to the definition. So if a given sequence is strictly increasing, necessarily it will be increasing. But there may be some sequence which are increasing but cannot be strictly increasing. Like some sequence, the first term might be 2, and the second also 2, and the third 3, 5, 7, and again 7 and 10. Generally it's increasing, we can say, but some terms are repeating here. When you see 2, the first two terms, here also at the middle some terms are repeating. So this is, we can say it is increasing, but we cannot say it is strictly increasing according to the definition. So I hope it is clear what means increasing and strictly increasing. Like by simpler example, we will see some more examples, but this is the definition. To be increasing, the nth term has to be less than or equal to the n plus 1th term. To be strictly increasing, the nth term, it has to be less than simply the n plus 1th term. What about decreasing? The same, it has to get smaller and smaller, but the nth term, it has to be greater than the n plus 1th term to be strictly decreasing. Otherwise, to say it is decreasing, the first term greater than the second, like that of like 3, 0, negative 3, negative 6. This is strictly decreasing, but there might be, it is strictly decreasing mean it is decreasing at the same time. But there might be some sequences which is generally decreasing but need not be strictly decreasing, as I mentioned before. But let us see the example here. The first example, what does it say? Show that what? The given sequence, the sequence is the one which is in the brace. Here it is, 3 minus 1 over n, strictly increasing. Okay, let us mention some of the terms. The first term, we can say A1, that is when you insert 1 it will be 3 minus 1, it will be 2. When you insert 1 in place of n, 1 over 1, it's 1. And the second term, A2, when you insert 2, 3 minus 1 over 2, it will be 5 over 2 or 2.5. The third term, A3, when you enter 3 minus 1 over 3, it will be 8 over 3, nearly 2.6. When you try to observe here the pattern or the increment, it is increasing, of course, from 2 to 2.5, again 2.6. But as n goes to infinity, as n goes to infinity, 1 over n will be 0. 1 over n means 1 over large number. When you insert here a very large number, 1 divided by a large number, nearly it will be 0. So as n goes to infinity, the given sequence will be 3 minus 0, obviously, it will be 3. So the last term will be 3, the first term is 2. So when you are trying to observe the pattern here, the minute is constant, 3, 3, 3. 3 minus what? First it was minus 1, and then minus 1 over 2, and then minus 1 over 3. The subtrahend is getting smaller. It was 1, then half, then 1/3, and then 1/4. It's getting smaller. So some constant number minus a number or numbers which are less than, getting smaller and smaller, the outcome will be larger and larger, as you see. So this is strictly increasing, obviously. But we can prove it like by the general formula. How to prove the general formula? Using the general formula, First of all, what is our sequence? Our sequence is 3 minus 1 over n. This sequence you can take it as an. According to the definition of a strictly increasing case, what does it say? An must be less than an plus 1. Let us apply this formula and let's prove it. The an is to be strictly increasing. This has to be satisfied to be strictly increasing. Okay, let us start with this assumption and then let's go on. So n means 3 minus 1 over n. It has to be less than 3 minus 1 over n plus 1. When we insert n in place of n here as it is, but when we insert n plus 1 it will be in this way, but the 3 both sides will be cancelled out. Here it is. What remain here, negative 1 over n is less than negative 1 over n plus 1, and then we can cancel both sides by negative. We can multiply, but the inequality sign obviously it will be changed. Then what remain here, 1 over n is greater than 1 over n plus 1. Then we can multiply crisscross. 1 times n plus 1 is n plus 1. It is greater than n times 1, it's n. Since n is an element of natural number, no need to worry, it's positive number, so you can multiply by crisscross. Now since n is a natural number, n plus 1 is greater than n. Yes, that is true. This is always true. You can take any counter example and check it. For example, since n is a natural number, if you take 5 plus 1 is greater than the number 5. That is true. So our assumption is correct. So the given sequence is, obviously it is strictly increasing. So we can proceed to the next example. The next example, it says show that the sequence 3 plus 1 over n is strictly decreasing. The same, we can mention some of the terms. If you insert 1 it will be 3 plus 1. If you insert 2 it will be 3 plus 1 over 2. If you insert 3, 3 plus 1 over 3, it goes. So the beginning is 4, and then the final one with as n goes to infinity, the whole term will be, it is 0. So finally it will be 3 plus 0 will be 3. So it was starting from 4 and it goes to 3, and at the same time when you are trying to see the consecutive terms, it's getting smaller and smaller, so we can conclude it is strictly decreasing. So we can prove also this one using the previous process, but no need to take time. That previous example is enough. So what means monotonic? Generally, a given sequence n is said to be monotonic or monotone sequence if it is either increasing or decreasing. For example, it says show that this is not monotonic. The given example is negative 1 the power of n the whole over n. This sequence, it will be, when we are inserting odd numbers as an exponent here, it will be negative 1 the upper, but the lower, it will be 1 over 1, then 1 over 2, then 1 over 3, then 1 over 4, and then 1 over 5. It goes, the denominator part, when I insert 1, 2, 3, 4, it goes increasing like directly, the denominator part only, when we are considering the denominator part. When we insert 1 it will be 1, when we insert 2, 2, then 3, 4, 5 goes. But the upper part, since it is negative 1 the power of n, it has two outcomes, either negative 1 or 1. When it will be negative 1 when n is odd, it will be 1 when n is even. So the first term it's negative, then the second positive, then negative, then positive, then negative, it goes. Therefore this sequence we cannot say it is increasing, or we cannot say it is decreasing. So it's neither increasing nor decreasing, so that this is not monotonic. To be monotonic, what is the definition said? The given sequence has to be either increasing or decreasing. The next example, look, try to see it. Decide whether or not each of the following sequences is monotonic. First one, the same like that of 3 minus 1 over n that we said, it was increasing. The same here, the constant or the minute is 8, but 1 over n, it is going the same way, like 1 over 1 it's 1, and 1 over 2, the subtrahend side is getting smaller and smaller, so constant minus a smaller number, it's getting larger and larger. So this is strictly increasing. The second one is strictly decreasing, like we said before, because when we insert 1, 2, 3 here, it's getting smaller and smaller. So like the number, if you insert 1, it will be 8 plus 1. 8 plus 1 is 9. This is the first term. As n goes to infinity, it will be 0, so 8 plus 0 will be 8. This is the last outcome and this is the beginning, but at the middle it's getting smaller and smaller. So this one is strictly decreasing and the A is strictly increasing. But C, it is neither, because -1 the power of n. It's because of that the given sequence is not monotonic. So A and B are monotonic, but the C is not monotonic. There are some exercise here given. We can do 1 or 2 questions from here. Let's do question number 6. Let's go to number 6. From number 6 it says use an appropriate method to show each of the following sequence converges, and we are going to show whether it is monotonic or not at the same time. So in the next video I'll be back with this solution, but as an exercise I will give you question number 6 to check whether it is monotonic or not. At the same time, what will be the last outcome, and is it a convergent or not. So hopefully you have got some idea what means increasing, decreasing, strictly increasing, strictly decreasing sequences. At the same time, what means monotonic sequence. Thank you.